Once we get going, as the note here says, we're going to be working with this worksheet today, so that you can find in Canvas. That's posted in Canvas, so it will probably be helpful to have that downloaded or printed out while we're working in Canvas together.
Yeah, I had a question.
Yeah.
I just wanted to make sure I didn't miss anything. It was just the quiz due before class today. Is that right?
That's correct. Yes. So quizzes will be due before class on Monday and Wednesday, and your kind of longer written assignment is due every Monday just before midnight.
Okay. And then sort of ungraded, but we have the expectation is we read through the material before we come to class.
That's right. So the idea is not necessarily to read through everything we're going to talk about in class, because some of this stuff that we're going to do, you might not have read, but it's more so I've tried to make the call about these are things that I think students have an easier time figuring out on their own, and these are some things that I think require some discussion. So the things that I think are a little bit easier to work out are the idea behind the reading quizzes, and things that are maybe we'll take some discussion to hash out those ideas. That's what I would like to use our time in Zoom to do.
Okay, great, thank you.
Okay, well, welcome everybody. We'll get started for today. So someone was asking about the workflow, if you kind of caught the end of that a little bit before. Every Wednesday, it's going to be a reading quiz that's going to be due, but nothing else is going to be due. So the homeworks are due on Monday. So I looked through, everybody did the quiz. Awesome. So far, so good. So I hope that went well. That's the gist behind the quizzes. So again, the quizzes are intended to be a little more straightforward. So hopefully it's not taking you, tons of time to complete those. Okay, so today we're going to continue talking about statements, combinations of statements. So you've looked at negations, conjunctions, disjunctions. We also want to take a look at conditional, biconditional statements today. So what you guys read about is a statement, right? That one thing I really want to be careful about as we're kind of going through this class is definitions are really important here. And the notation and the terminology that we use is very important. So when we say statement, that might mean something in a non-mathematical sense, but in a mathematical sense, that means something very specific. And that would be, that's a statement that we can determine, or that's a statement that is either true or false, can't be both, can't be unknown. So for something like this first statement, 121 is a prime number. What do you guys think? You can give me a thumbs up if you think it's a statement, if you know how to do that. Yeah, you can do a real thumb or a fake one, whatever you prefer. Okay, so that is a statement. My next question would be, is that a false or a true statement? Yeah, that's good, that works. Okay, so that is a statement, it's false. So it's not that it needs to be true for it to be a statement. It's just that we need to be able to ascertain whether it's true or false. That's right, so this one would be a statement, yes. And something like, go wash my car, is that a statement? That is not, right? We don't know if that's true or false, that's a command. So that there's no logical truth to that or not. So this equation in 3, that's actually a mathematical sentence, right? It's saying the expression x squared minus 5x minus 6 equals 0. Is that a statement? What do you guys think? Some say yes, and some say no. Is this true or is this false? So if you think this is a statement, then is it true or is it false?
If it's a statement, it doesn't matter if it's true or false, so long as it can be proved to be true or false, right?
That's right. So what do you think? Well, and some of them we can say certainly that they're either true or false, and some of them we might not be able to. So is this
open-ended?
This is open-ended, that's right. So this is what we would call an open sentence. Because its truth depends on the value of x. If x is equal to 0, for example, that is false. If x is equal to -1, then that suddenly is true. So something like this is not a statement. We would call this an open sentence. Okay, and again, open sentence means it will be true for some values of x, it will be true, or will not be true for other values of x. So these things are statements that are either always true or always false, right? And if it's sometimes true and sometimes false, then it wouldn't be a statement. Okay, she is a big Star Wars fan. What do you think about that? Not about Star Wars, about the sentence itself. Seeing some yeses. This is actually not a statement. Does anyone know why this wouldn't be a statement?
Is that depend on the who she is?
Yeah, it's an open sentence again. Our variable is now she, right? And you plug in different women for she, and some people will say yes, and some people will say no. So for each person, that's either a true or a false statement, just like the previous one is for each value of x. But its truth depends on the person that we pick. So this would also be no, it's an open sentence. So if instead it was, I am a big Star Wars fan, well, that would be a statement, right? Depending on the person, that would be true or false, but there's only one person being referred to in that statement. Okay, and so I think we're getting the idea here. I think all of the other ones after that are all statements. Some of them are true, some of them are false, and some of them we don't know. So for example, there exists a 7-foot tall purple giraffe on the moon. This is a statement. It's either true or it's false, right? We just don't know if it's true or if it's false. I assume it's not true, but I guess I haven't been all over the moon, so I can't be certain. Okay, so any questions about this idea, this notion of what a math or a logical statement is? Okay, and so just so you all know, yeah, a couple of things I want to announce before we jump into some of the new content today. And that is, I posted an announcement. So because the course roster is changing slightly, I think the easiest way to make sure that everybody gets announcements is to send them as announcements in Canvas. So please make sure you're checking the Canvas announcements as opposed to me sending an email. And so I did post an announcement about the playlist where you can find all of our videos. And let me just share our Canvas site real quick. And so here's the Canvas page, and I just put a link to it. This is the wrong class. Let me get into our class. Yeah, so here's our class, and there's a link for the YouTube playlist over here. And this will take you into YouTube, and I'll order them over here. So I'll just say that the Zoom recordings take a while to upload because they're long and it takes a while for YouTube to process them. So like today's, I won't be able to probably get it processed, and I usually post it in the middle of the night, and when I wake up in the morning, they're done. So this will be up in the morning, but these are like an hour-long video. So I was just trying to say that I put bookmarks in them so you can hover over the video to see what question is being talked about in what part of the video rather than have to scroll through the whole video. So hopefully that makes it a little bit easier to find what you're looking for in the midst of like a 50-minute or 1-hour video. And then other than that, I just wanted to be sure that you guys all know what is due on Monday. So on Monday, there's homework 1, which is going to be due at midnight. And there's a pre-class quiz for Monday. The quiz is already up. I haven't posted the video yet. I really don't, I'll make one. I like making videos. I think you should be able to answer the questions reading the material alone. So if you don't want to wait for me, I'll get the video up tomorrow, but if you want to take it later today, you probably can just read the materials and answer it. So when you click on the quiz over here, is locked, so you can't see it. You'll have to wait until after class. But there is a link to the reading materials, and I'll add a link to a video once I get that done. All right, questions? Okay, so if you've got that worksheet, we're gonna be working with that the whole class. So this was the worksheet called Statements and Combinations. Yeah. And this is posted in Canvas if you didn't catch it. So the first page looks pretty familiar. So we went through a bunch of these. I'll just leave this for you. If you want some extra practice, I'll put up all the solutions to those if you want to check your answer on some of those. So first, I just want to make sure we touch on the stuff that you guys read or watched. So you should have read about statements, conjunctions, which is joining them, 2 statements with an and. The disjunction is combining 2 statements with an or, and then we have the negation of a statement. And so the notation looks kind of similar to set notation with unions and intersections, right? Except now we don't have rounded things, we have V's and wedges and things like that. So you had a reading question that was like this. So Colorado has mountains, that is a true statement, and Colorado borders an ocean, that is a false statement. And so now if I take P and this symbol over here means and Q on the quiz, pretty much you guys did this correctly. You said that this one would be false, right? Because the conjunction is only true if they are both true, which would not be the case here. And the or conjunction or the disjunction would be true because in order for the disjunction to be true, we just need one of those statements to be true. And the negation of Q, which in this case, the Q is Colorado borders an ocean, right? The negation of that would be Colorado does not border an ocean, and that is true. So if Q is false, the negation of it would have to be true by definition. Okay, any questions about that? Okay, good. So what I want to spend the time on today then is thinking about conditional statements, biconditional statements, if, then, if, and only if. I would say this is not a course in logic, though that's where we're starting with. Really what we want to learn here is how to write mathematical proofs. That certainly involves clearing up some details of logic. But for us, we're mostly going to be proving conditional statements or biconditional statements. If, this, then, that. These things should look pretty familiar, sound familiar in mathematics. So that's what I want to really focus our time on when we're thinking about logic. Okay, so a conditional statement is an if and a then. And we call the P, if P is called the hypothesis, Q is called the conclusion. And I think it would be really handy for you, in some sense, we're going to be learning like another language, and we're going to be picking up some new symbols, and it might be helpful to have a nice dictionary of symbols organized someplace for yourself. So the reading quiz that is due for Monday is all going to be multiple choice. What does this symbol mean? What does that symbol mean? That sort of thing. One of them will be this symbol right here, right? So it's going to ask you, what is the symbol for a conditional statement? And that's this arrow over here. So it looks like a very unspecial symbol. That symbol actually has very special meaning in mathematics. Okay. So I was thinking about coming up with some question, and I was thinking about Pink Floyd for some reason. If anybody's a fan, if you don't eat your meat, you can't have any, what is it? If you don't eat your, you can't have any pudding if you don't eat your meat, right? So here, my pudding was my dessert. And instead of meat, we're going to talk about vegetables. We'll be vegetarians. So let's say the following implication here is, okay, if you eat all of your vegetables, then you will have dessert. And the idea here is what I would like to do is ascertain how to tell whether a conditional statement is true or false. And as you hopefully saw in the videos, we can do that with what's called a truth table, which is what's over here on the right. And so these are a little bit different. We're not joining them with an and, we're not joining them with an or. So one thing that you can think about here as far as determining whether or not this statement is true or false is you can think about whether P and Q being true or false would imply that the original statement here was a lie. So let's say the original statement was, if you eat all of your vegetables, then you will have dessert. So let me just do one of them, and then I'm going to want to have you guys talk about this in some groups. So if P is true and Q is true, we're over here. And if I want to determine whether this is true or false, then what I could say is P being true means I ate all of my vegetables. Q being true means I have dessert. So if that's the case, if I do eat all of my vegetables and my parents do give me dessert, they kept their word, right? So that's true. So if I eat my vegetables and I get dessert, they told me the truth. So that's how you can start to think about some of these. That might be kind of a down-to-earth way to think about it. Then the next one would be, okay, what if I ate all of my vegetables, but I didn't have any dessert? What does that mean? Did my parents lie to me or not? So these are the types of things I would like you guys to discuss amongst yourselves. So in other words, I'm going to ask you just to complete that column. But in addition to just completing the column, it'd be useful if you guys are sharing your thinking and your logic to each other as to how you came up with true or false. Okay, any questions before I break us up? Okay, okay, we'll have rooms of 3 or 4 people per group. So let's take about maybe 5 minutes to talk about these, and Nat and I will try and circulate through your room. So Nat, when I split these up, you'll probably get assigned to a room. Do you mind just not going to that room for a few minutes and we can chat, Nat? Okay, good luck everyone. Take about 5 minutes. What you said about 7a, what the negation of that would be? You guys, anyone?
So it's a
Yep.
function is differentiable and not continuous.
That's right. So we keep the hypothesis true and we negate the conclusion. That's right. So here we would say f is differentiable and not continuous. Okay, and just keep in mind this original statement is in fact true. If a function is differentiable, it has to be continuous. The negation of this statement is definitely not true. There is no such thing as a differentiable function which is not continuous. Okay, somebody else want to share what you did for the negation of B?
Yeah, I can.
Okay, thank you, Stephanie.
So you'll wash my car today, and you won't get an A in Math 3000.
That's right. Right, so you wash my car. It's really clean. It hasn't gone very far, so that's the good thing. You wash my car, and we negate the hypothesis, and you don't get an A. Okay, so it's interesting when we actually negate a conditional statement, we don't get a conditional statement back. We get a conjunction back. Okay, so anyone think of an implication that we could write to express satisfaction guaranteed or your money back?
If you are not satisfied, you will get your money. Then you will get your money back.
Okay, if you are not satisfied, then you get your money back. Okay, so that's like the original statement here. And so if we negate this, then what would we get?
If you are not satisfied, then you will not get your money back.
So remember, we can take the if away, and right, we're going to say you are not satisfied. That part is true.
And you don't get your money back?
That's right. And you don't get your money back. So we negate the conclusion.
So the removing the if and then we assume those are included, or is that intentional for proper negation?
So in the negation, when we negate a conditional statement, we get an and statement back, not a conditional statement.
Okay.
Yeah. So what we're saying is that is going to be wrong. It's not if the hypothesis is true, only when the hypothesis is true and the conclusion is not. Yeah.
Okay.
And one thing that I haven't mentioned here, and that is, if we negate the negation, what do you think happens? What would you like to happen? Maybe I should say it like that.
Well, does that change the beginning of it? Would it change it to you are satisfied and you don't get your money back?
Right. So one thing is that if we negate this statement over here, remember this is an and statement. So if I want to negate something that looks like R and S, then remember that means we negate R or we negate S. And so that's what we would want to do here. So we have an and statement, and I would like to negate that and statement. So what I do is I negate the first thing. You are not satisfied. Negated would mean you are satisfied. And now we change that and to an or, and then we negate the second part of it, which is you don't get your money back. If we negate that, that would be you do get your money back. And let me just say that when we do that, we get something back which is logically equivalent to what we started with. Saying you are satisfied or you get your money back is the same thing as saying satisfaction guaranteed or your money back, right? So we kind of get back exactly what we started with. So the point here is it works the same like when you double negative undo each other, the same thing here. When you negate a negation, you get back the original statement. So in other words, if you were to negate the negation of P, you just get back P. Okay, so I think I will stop here since I don't think we can show this in 2 minutes, but this might be something, not homework, but it just might be something good to think about over the weekend. We're gonna come back on Monday thinking about the beginning of chapter 4, which is proofwriting. So this is really a class in proofwriting. So I just wanted to spend like the first week just getting some of the basics of the logic down, but I really want to just focus on how we can use this logic to prove things. They have entire classes in logic, and this is not one of them, so I don't want to spend too much time on the logic here. But this could be something to think about. Here it's asking you to prove something. This is our first proof. So see if you can use some of the information that we've proven today so far to therefore deduce a new statement. But we can pick up on Monday with this, and we'll start our introduction into proof. So we'll start chapter 4 just a little bit. The reading quiz for Monday is really just going to be, what does this symbol mean? What does that symbol mean? And so on. But I can make a little video to try and explain those as well. But I think you could probably jump into the quiz and take it without a video as well. Okay, well, thanks everybody for your attention and your participation. Have a nice afternoon. If you do have any questions about the homework, I have office hours tomorrow. Nat has office hours on Friday, and then your homework is due on Monday. So we're around to help you if you have any questions. Okay, otherwise have a nice afternoon and a nice rest of the week, and I'll see you after the weekend.
Thank you.
Thank
Yep.
you.
Thanks.
Take care. Thanks.
Yep.